In this example, we are given that the body length, y, or we could also call this f of x, in inches, so my output represents inches, of a walrus calf can be modeled by this function right here. X represents the calf's age in months. So explain what the 5 and the 42, what do these numbers mean? Okay, so 5, this is the rate of change. And 42 is my y-intercept, which is my initial value. Okay, so that's not what they represent. Just remembering that the 5 is the rate of change and 42 is the initial value. So what does the rate of change mean in this problem? 5. Okay, well, it's positive, which means it's going up. So my rate of change is 5 over 1. My y represents inches. My x represents months. So every month, the walrus calf grows by 5 inches. Okay, so the rate of change, 5, represents the 5 inches per month that the walrus calf is growing. 42 represents the initial value. So at birth, the walrus calf was 42 inches. Okay, so the initial value is 42 inches to start, and then every month after that, it grows by 5 inches. So evaluate f of 10. So f of 10, which means x is being played by 10, every time I see an x, plug in 10. So 5 times 10 is 50. 50 plus 42 is 92. So 10 is equal to x, and f of 10 is equal to 92. X represents the age in months, and the output represents the body length. So what does this mean? It means in 10 months, the walrus calf will be 92 inches. Okay, the x represents the months, the output represents the body length. So you plug in 10 months, you're going to get out 92 inches. All right, now not every situation is going to be linear. Okay, but we can use this idea of an average rate of change in order to look at just a snippet of a situation to give us a trend of what's going on. So in this example, on an 8-hour road trip, Haley decided to check how far she was from her family's destination on her GPS every hour and mark down the distances. So part A, on average, how fast was Haley's family traveling after 4 hours? So I'm looking here on the interval from 0 to 4. Okay? So this is my x1, y1. This is my x2, y2. All right? So I have these 2 points that I'm trying to find the rate of change for. So my slope, or my rate of change, I'm going to subtract the y's over the x's. All right, and then if I subtract that, that's going to be negative 240 over 4, which is negative 60. So negative 60 miles per hour. Okay, that is the unit rate here. What does that mean? How fast was Haley's family traveling after 4 hours? They were traveling 60 miles per hour. Okay, now I understand that the slope was negative there, but they're traveling at a rate of 60 miles per hour. All right, which means that the distance away from their family's destination is going away at a rate of 60 miles per hour. Okay, so they're traveling at a rate of 60 miles per hour, or they're getting closer to their destination 60 miles an hour. All right, for the entire trip, though, what was their average speed? So this is going to be the entire interval from 0 to 8. Okay, so this is still going to be x1, y1. And then over here, it's going to be x2, y2. So I'm finding the slope between 0, 470 and 8, 0. So my slope is 0 minus 470 over 8 minus 0. So that is going to be negative 470 over 8. That's going to be negative 58.75 over 1. All right, so they're getting closer to their destination. They're knocking out about 58.75 miles per hour. So their average speed for the entire trip is 58.75 miles per hour. Okay? Let me know if you have any questions. Notice how, actually, before I finish up this video, notice how these are not the same, which means this table is not a linear function. Okay? It's not a linear function, but we can look at it and figure out the trend of what's going on. Obviously, from hours 0 to 4, you're going faster. They're going 60 miles per hour. But overall, this entire 8-hour trip, their average speed was 58.75 miles per hour. Okay? If you have any questions, let me know. Other than that, make sure to knock out these practice problems.